The remainder and factor theorems. The remainder theorem. If a polynomial f of x is divided by x minus k, then the remainder is equal to f of k. This means you can use synthetic division to evaluate polynomials. The remainder is the answer. Okay, so let's try this. So f of 3, if f of x equals 3x to the third minus 4x squared minus 5x minus 12. So in synthetic division, we need to put each one of our coefficients inside the box. So 3, -4, 5, and -12. And so in this theorem, we are going to be dividing by 3, and our remainder will be our answer. Okay, so in synthetic division, the first thing that we do is bring down our first coefficient, so 3. Then we multiply. 3 times 3 is 9. -4 plus 9 is 5. 3 times 5 is 15. -5 plus 15 is 10. 3 times 10 is 30. -12 plus 30 is 18. So our remainder here is 18. So f of 3 equals 18. All right, let's try this again. So the first thing I need to do is put each one of my coefficients inside of my synthetic division box. So I'm going to have my 1/2, -3, 0 because x squared is not represented, 6, and -10. Okay, so I'm going to be using 4 as my divisor. Okay, so now I need to bring down my first coefficient, so 1/2. So -4 times 1/2 is -2. -3 plus -2, -5. -4 times -5 is 20. 0 plus 20 is 20. -4 times 20 is 80. 6 plus -80 is -74. -4 times -74 is 296. -10 plus 296 is 286. So 286 is my remainder. So my answer is f of 3, or f of -4. That should be f of -4 f of -4 equals 286. Okay, so that was the remainder theorem. So now we're going to take a look at the factor theorem. The factor theorem states a polynomial f of x has a factor of x minus k if and only if f of k equals 0. So if k, or x minus k, divides into a polynomial evenly, it is a factor of that polynomial. This means you can use synthetic division to help factor polynomials. Okay, so we're going to check to see if x minus 4 is a factor of x to the third plus 3x squared minus 18x plus 38. So the first thing I need to do is put each one of my coefficients inside my synthetic division box. So 1, 3, -18, and 38. Then I need to set my x minus 4 equal to 0, so 4. So 4 is going to go on the outside of my synthetic division box. Now in synthetic division, I bring down my first coefficient, 1. Then I multiply 4 times 1, which is 4. 3 plus 4 is 7. 4 times 7 is 28. -18 plus 28 is 10. So 4 times 10 is 40. So I have a remainder of 78. So if you have a remainder, that means that this does not go into this equation evenly. So this is not a factor. Okay, let's see if z plus 2 is a factor of z to the fourth minus 3z squared minus 4. So I am missing a z to the third and a z, so I need to represent those with zeros. So I'll have 1, 0, -3, 0, and -4 inside my synthetic division box. Okay, so I need to set my factor equal to 0. So x plus 2 equals 0. So x equals -2. So -2 will go on the outside of my synthetic division box. Now I'm going to bring down my first coefficient, 1, and multiply -2 times 1, which is -2. 0 minus 2 is -2. -2 times -2 is +4. -3 plus 4 is 1. -2 times 1 is -2. 0 minus 2 is -2. So -2 times -2 is 4. -4 plus 4 is 0. So there is not a remainder. So that means that this z plus 2 is a factor of z to the fourth minus 3z squared minus 4. Using the factor theorem. So first, divide the polynomial by the given factor. Write your answer as a quotient. Factor the quotient. Write all factors of the polynomial. Solve each factor if necessary. Okay, so factor 2x to the third plus 11x squared plus 18x plus 9, given that f of 3, -3 equals 0. So this is the same as x plus 3 equals 0. So x equals -3 is a factor. So, or x plus 3 is a factor. So our -3 is going to go on the outside. And then we need to make sure that we put each one of our coefficients on the inside. So 2, 11, 18, and 9. Okay, so now we need to bring down our first coefficient, 2, and then multiply -3 times 2, which is -6. 11 plus -6 is 5. -3 times 5 is -15. 18 minus 15 is 3. -3 times 3 is -9. 0 plus -9, or 9 plus -9 is 0. So it already told us that this was a factor, so this is good. We do not have a remainder. So that means that that x plus 3 is a factor. So now I need to write my quotient. So remember that when we use synthetic division, we use one less degree than the highest degree. So instead of using a 3, we're going to use x squared. So we're going to have 2x squared plus 5x plus 3. Now we have to factor 2x squared plus 5 plus 3 to get my two other factors. Okay, so first I need to multiply a times c. I get 6. Now I need to find two numbers that multiply together to equal 6 but add together to equal 5. So 2 and 3. So x plus 2 and x plus 3. Then we bring down our a. Then we simplify and bring 2 out to the front. Okay, so these are my two factors. So x plus 3 was a factor, and x plus 1 is a factor, and 2x plus 3 is a factor. So that is factoring. Okay, so this says factor x to the third minus 11x squared plus 14x plus 80, given that f of 8 equals 0. So remember, f of 8 equaling 0 is the same as x minus 8 equals 0. So we need to put down each one of our coefficients inside of our synthetic division box, and that 8 is going to go on the outside. We bring down our first coefficient and then multiply 8 times 1, which is 8. Negative 11 plus 8 is negative 3. 8 times negative 3 is negative 24. 14 plus negative 24 is negative 10. 8 times negative 10 is negative 80. 80 plus negative 80 is 0. So this proves that x minus 8 is a factor of this equation, or this polynomial. So we will use one less degree. So this will be x squared minus 3x minus 10. Now we need to factor. So I need to find two numbers that multiply together equal negative 10, but add together to equal negative 3. So 1 and 10 doesn't work, but 2 and 5 does, where my 2 is positive and my 5 is negative. So x plus 2 and x minus 5. Okay, so these are all my factors. So x plus 8, x plus 2, and x minus 5. Okay, so it says 1, 0 of f of x equals x to the third minus 2x minus 9 plus 18 is x equals 2. Find the other zeros of the function. So I'm going to find my factors and then set each factor equal to 0 and solve. So I'm going to use synthetic division to do this. So we already know that one of my x's is 2. So this means that one of my factors is x minus 2 equals 0. So 2 will go on the outside of my synthetic division box. Then I need to make sure I represent each coefficient. So I'll have 2, negative 9, and 18. So I need to bring down my first coefficient. So 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. Negative 9 plus 0 is negative 9. 2 times negative 9 is negative 18. 18 plus negative 18 is 0. So this proves that 2 is a factor of this polynomial. So we need to find the two other factors. So my highest degree is 3. So my first degree here is going to be 2. So I'm going to have x squared minus 9. So this is a perfect square binomial. Perfect square binomials, remember that you're going to have the square root of x squared, which is x, and the square root of 9, one positive and one negative. So I'll have x plus 3 and x minus 3. Okay, so my factors are x minus 2, which we already knew, x plus 3, and x minus 3. But that's not what it was asking for. It's asking for my zeros, my solutions, my roots. So I need to set each one of my factors equal to 0 and solve. So my zeros or roots or solutions are x equals 2, x equals negative 3, and x equals 3. Okay, let's try another one of those. So it says 1, 0 of f of x equals 2x to the third minus 9x squared minus 32x minus 21 is x equals 7. Find the other zeros of the function. Okay, so this x equaling 7 is the same as x minus 7. So this is one of my factors, and x equals 7 is one of my zeros. So I can use synthetic division to help me find my other two factors. So I need to put each one of my coefficients inside my synthetic division box and have my 7 on the outside. Then I need to bring down my first coefficient, 2. 2 times 7 is 14. Negative 9 plus 14 is 5. Negative 32, 7 times 5 is 35. negative 32 plus 35 is 3. 7 times 3 is 21. Negative 21 plus 21 is 0. This proves that x minus 7 is a factor of this polynomial. Okay, so I'm going to have 2x squared plus 5x plus 3. So now I need to factor. Remember, when we have an a other than 1, we need to multiply a times c. So 2 times 3 is 6. So now I need to find two numbers that multiply together to equal 6 but add together to equal 5. So 2 and 3. And then we need to bring down our 2. So I'll have x plus 1 and 2x plus 3 are my other factors. So my three factors are x minus 7, x plus 1, and 2x plus 3. But it wasn't asking for my factors. It was asking for my zeros or my solutions or roots. So I need to set each one of these equal to 0 and solve. So my solutions, zeros or roots, are x equals 7 and x equals negative 1 and x equals negative 3 over 2. So that is how you can use these theorems to find your solutions, roots, or zeros.